Welcome back. In this final video on volume, we are going to put the lesson together. In the previous videos, we studied 4 examples: a right triangular prism, a cylinder, a triangular pyramid, and a cone. At first, these ideas may look like separate facts, but they are really built around just 2 main ideas. The first is stacking equal layers. For prisms and cylinders, the cross-sections parallel to the base stay the same all the way through the solid. That means we can think of them as stacks of identical layers. For these, we have that volume is the area of the base times the height. So as a reminder, the capital B means area of the base, and H is the height. And this mainly works for 2 big objects: prisms and cylinders. These are all stacking equal layers, and this formula will work for all prisms and all cylinders. The second idea is shrinking to a point. For pyramids and cones, the solid narrows as it rises. So even if the base area and height match a prism or a cylinder, the volume will be smaller. In fact, for these, our volume is going to be 1/3 base times height. And this is going to work for pyramids as well as for cones. The examples we did in the previous videos show that the formulas are not random. They come from the structure of the shapes. As future teachers, here are some valuable ideas to emphasize. First, volume is measured in cubic units. Next, the base area matters because it describes one layer of our shape. The height will tell us how many layers or how tall a solid is. And pyramids and cones are not full stacks. They taper, so they use 1/3. A few common mistakes students might make include mixing up surface area and volume, forgetting to find the base area first, using the slant height of the cone instead of that vertical height, forgetting the factor of 1/3 for pyramids and cones, or using square units instead of cubic units. These are all normal mistakes, and they can lead to excellent classroom discussion. A helpful teaching question is, does this solid keep the same cross-section all the way through, or does it shrink to a point? That question helps students decide which kind of formula makes sense. You've now worked through some important volume ideas. You connected formulas to structure, solved examples, and compared different solids. That is strong mathematical reasoning. Keep going. Keep asking why formulas make sense. And remember that understanding grows through careful thinking. That is exactly the kind of mathematics that helps future teachers feel confident and prepared. Great work.